All right, today guys, we're gonna talk about something called projectile motion. So anything you throw in the air, anything that's shot, fired, thrown, tossed is a projectile. And because of the way our earth works, we have gravity. What goes up must come down. This is one of the foundational concepts of where quadratics are seen in the real life. Where could I apply what I'm learning here in our real life situation? So, for example, let's start off with a very simple problem. It's where we're going to apply, if I kick a ball at X number of velocity, how far will that ball go? Okay? If I hit a ball with a tennis racket, how far is that going to go before it hits the ground? Okay? So, we have a couple of ways we can do this, a couple of problems. So let's talk a little bit about what these would be. So the first problem is based off a soccer ball. A soccer ball is kicked in the ground with initial upward velocity of 90 feet per second. The equation, which I'm going to give you every time, is h equals 16 times t squared plus 90t, where h is height and t is seconds. So one of the most common things you're going to want to think of is how high will that ball go? So when you're thinking in terms of a quadratic equation, we're looking at our since we're going up, our highest point will be right here, right? And that's another way to say the vertex. So if I see either the maximum or the minimum, I'm really thinking I'm going to use my vertex. I'm going to go find vertex, so that's the opposite of B all over 2A is going to give me my answer. And that's going to tell me how I find my answer. So my time, my T, is going to equal this. So if I've got my T here, the maximum height of the ball is negative 90, so the opposite of B, over 2 times negative 16. Okay, so now this is going to give me my vertex. It's going to tell you how much time it's going to take to get up to here. So that's going to roughly equal approximately 2 81/100. Okay, so 90 divided by 32, we'll go to decimals. It's going to be easier to work with than fractions. I know I said it, decimals easier than fractions. So that's going to give me the time it's going to take to get to this point. To find my height, I'm going to put my time in. Get rid of all my notes over here so I have some space to work. Get rid of all of this so I have some space to work. There we go. With that, I'm going to put T in place of here. This gives me the time. So H, which is my height, will equal negative 16 times 2 81/100 squared plus 90T, 90 times 2 81/100. So this is where you just bust out your calculator and you type this in. Click, click, click. And I found out that H was equal to 126 56/100 feet. So this person kicked their ball roughly 40 yards in the air. It's pretty high. It's definitely higher than the school, probably a spot as high as the stands in the football stadium. Okay? Now the question would then be, well, if he's kicked it that high, how long is it going to stay in the air? Okay? So how many seconds will it take to land? So a ball will go up and then it will come down, right? So what's my H going to be? I'm going to set my H is equal to 0 because I don't want my 0 time here to be 0. I want to find over here. So if I do my H is 0 on one end, if I do my time being 0, that's my issue. So I'm going to say, okay, I know H will be 0 from here to here. So I'm going to come into the pi problem. 0 is equal to negative 16 times t squared plus 90t. So this is going to break out and go, oh, okay. This is either a quadratic equation, doing the quadratic formula, or can I factor it? Is there a GCF? What can I do? So I'm going to come in and I'm going to look and say, can I factor it? Well, they both factor by t, and they're both divisible by 2. So let's go ahead and do my GCF. So I get 2t is equal to, and we're going to make it -2 because that's going to be 0 time. That's going to be our starting point. And then, 8t plus 45. Those are my two factors. So I'm going to say, well, this one, we know it's 0. It can't be less than 0. So we're going to say we're not worried about t can't approximately 0. So we're going to come over here and solve this one. 8t minus 45 is equal to 0. We subtract 45, so we get 8t is equal to 45. Divide by 8. We're going to say roughly about 5 5/8 seconds, which would round to 5.625 seconds. Okay, so you can see that's roughly how long it took to reach the bottom. Let's take a look at another style problem. This time we've looked at the maximum height. Let's try another one. So take an apple and launch it directly upward at 64 feet per second from an 80-foot tall platform. So I'm not starting at 0, I'm starting at 80. And you'll see that's reflected here as your C term. The equation of the apple's height h at the time t after launch is h equals -16t squared plus 64t, that's our initial velocity, plus 80. So we find the maximum height of the ball. This is just like we talked about before, so you're going to start by using your vertex and then finding the answer for h once you have that vertex. So pause the video and see what you come up with for number 2. So you came up with the opposite of A is, opposite of B is 64 over 2 times -16. So this time you get -64 divided by -32. You get your t is equal to 2. So it's going to be its vertex in 2 seconds. That's the highest it's going to go. So you're going to come up and go, okay, -16 times 2 squared plus 64 plus 80. Sorry, I wrote that wrong. My apologies. 64 times 2 plus 80. So you get your answer over here. So 4 times -16. And again, you're going to use your calculator on this, but I'm going to go ahead and do it longhand just on this one because it's something we can do in our head. 4 times negative, so it's -64 plus 128 plus 80. You get your math worked out. You end up finding it's 144 feet is going to be the maximum height it reaches. So slightly higher than the tennis ball in the first problem, or not tennis ball, the soccer ball kicked in the first problem. Probably because it was up 80 feet higher than the initial soccer ball kick. Okay. The last problem you're going to do is how long is it going to take to reach the ground? So again, that reach the ground tells me that I want my h to be 0. Okay. If I ever say reach the altitude of 5 feet, then you put 5 in for h, and that would help you solve your problem. Okay. So again, let's come down and take a look at this problem. Let's put it into the equation. -16t squared plus 64t plus 80. So I'm going to think in my way, how can I do this? What can I do to this problem? So let's start with think, is there a GCF? So I'm going to try my factoring first. That's going to be the fastest. And it happens to be, Siri, go away. They happen to both be divisible by 16. So I'm going to factor everything by -16. So I'm going to say -16 is equal to t squared minus 4t minus 5. I keep trying to write a plus when I don't need to. Minus 5. Now I can think what multiples of 5 add up to 4, and that's going to break it down into a -5 and a +1. And then I've got my -16 on the outside. So now what I can do here is solve my problem. So if I factor this out, I get t plus 1 is equal to 0. T is equal to -1. That can't happen because you can't have less than 0 seconds. So let's come to the other side. T minus 5 equals 0. So t is equal to 5 seconds. Okay, so that's going to be the point. It's going to take 5 seconds to reach the ground after you shoot it in the air. Okay. All right. We're going to skip over number 3 and take a look at a question like number 4. And then I'm going to have you guys try a couple, and then you have your homework to do. All right, so let's take a look at number 4. A penny is dropped from the Empire State. I swear, I feel like I had this discussion with y'all a couple of, at the beginning of the year somewhere. Is dropped from the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled as an equation, because you kind of toss it, okay, how long will it take the penny to strike a 6-foot tall person? So it's going to change our answer, our way we write it. That's why I wrote this one for us. We're going to set it equal to negative 16t squared plus 1,250 is equal to, this time, instead of being 0, it's going to be equal to 6. So the first thing we're going to do is solve and make it equal to 0. Negative 16t squared plus 1,244. Okay? So now I can solve my problem. Okay? I've got just a t squared here. I don't have t on the other end, so I can make this even easier. I could do my quadratic formula, or I could solve it like a regular equation and subtract 1,244 from both sides. Negative 16t squared equals negative 1,244. Then work my next step, divide both sides by negative 16. I'm out of space, so I'm going to move mine over just a little bit so I can do my work again. Okay, so I get t squared is equal to the square root, sorry, not the square root, not yet. T squared is equal to 77.75. And then I take the square root of both sides. So t is roughly equal to about 8.82 seconds, plus or minus 828. So, and it's really going to be a positive because it's going to take 8 seconds to drop that far. For a penny to drop 1,250 feet takes roughly 8 seconds. Almost 9. All right. All right, so I want you guys to try both number 5 and number 6. Pause the video and see what you come up with. All right, now that you've had a few minutes to work, let's have you try number 6. The first thing we have to do to figure out on number 5, my apologies, is figure out what's it asking me to do. Fired vertically into the air, initial velocity equation modeled, how long, so I'm looking for t, to reach the ground. So those two give me the hint. 0 is equal to negative 16t squared plus 80t. Now in this case, I can't just solve for t because I actually have 2 variables. So I'm going to look, can I factor? So let's start there. Can I factor that? I can. 16 and 8 are both divisible by 16. So I'm going to factor out 16t and then get t plus 5. So we do our math here. We know time can't equal 0. That's not where it's going to reach the ground. That's where it's going to start in our projectile motion. That's there. I want to figure out where it's going to hit over here. So that's going to be here. Sorry. Apologies, it's t minus 5 here, because that should be a negative 16. So when I solve it by t is minus 5 is equal to 0, I get my time is equal to 5 seconds. To get here, it's 5 seconds. So it will reach that ground. My next question you guys worked on was the Apollo chariot, a roller coaster at Busch Gardens, moves at 101 feet per second. Nice, pretty quick. The equation of a ride can be represented as negative 16t squared plus 101t plus 10. What is the maximum height reached of this ride? So now again, what we look at, it said maximum, so I need my vertex. So the opposite of b, 101, divided by 2 times negative 16, gives me approximately, we'll go 3 and 1600ths, you could say 3.2. And now I can plug that in. Negative 16 times 3 and 1600ths, squared plus 101 times 3 and 1600ths plus 10. So now I can do the math. I'm going to type that all in my calculator, and I get roughly 12 and 2500 seconds. Sorry, apologies. That's the wrong question. I looked at the wrong answer on my paper. 169 and 3900ths feet. Sounds good. Okay. All right, the last question, and this is your true rocket science. Not true. You'll notice these two are different. Negative 16 is our approximation for gravity on the Earth, just in case you were ever wondering. The velocity, an astronaut throws the moon throws a baseball upwards of the initial velocity of 10 seconds, letting go 2 meters above the ground. The equation of the basketball pathway can be modeled like this. The same experiment is done on Earth. There's an approximation of gravity there. How can it be modeled? What's the difference? Okay, you're going to figure out how much longer it would stay in the air in the moon, which has a much lighter gravity than on the Earth. So you're saying, okay, how much longer will the ball stay in the air? So what are we thinking? We're thinking it's probably going to roughly be, I need to factor this. So in my brain, I'm looking at this, I can't factor that. I probably can't factor that either. So I'm going, ooh, I know what I can do when I can't factor. I can do my quadratic formula. Negative b plus or minus the square root of b squared minus 4ac times 2 divided by 2a. So let's put that in. So, okay, let's do our math here. All right. Negative 10 plus or minus the square root of 10 squared minus 4 times 0.8 times 2 all over 2 times 0.8. So I get this all simplified down. My discriminant is 100 plus 6. So I get negative 10 plus or minus the square root of 106 over 1 6/10. So now I'm actually going to use an approximation for this and say, okay, that's roughly, if I put that into my calculator, negative 10 plus or minus, if I do my negative, that's roughly a little over 10, okay? So if I do negative 10 minus negative 10 over 1.6, okay? It gives me negative 20 over 1.6. That gives me a negative answer. That doesn't work. And then negative 10 plus 10.6. So I get 6/10 divided by 1/6. So I'd be somewhere around like 0.2 divided by 1.6. I'm going to get roughly 12.7. Okay. My last question I'm going to come over here and do is I want you guys to figure out what the gravity would be on Earth. All right, so pause the video and see how long it would last in the air. All right, so again, we've got our negative 10 for A, plus or minus the square root of 10 squared, minus 4 times 4.9, minus 4.9, plus 2. So this time I get negative 10 plus or minus the square root of 139, which is just under 12, divided by negative 9 8/10. So I'm going to put that into my calculator, and I get roughly 2 and 2200ths. And then the question is, how long will the ball stay in the air comparatively? So you'd subtract the two numbers and get 10 and 4800ths seconds. So it'd stay in the air on the moon about 10 seconds, 10 and a half seconds longer than it would on the ground. All just really interesting math. Your homework is really only 4 problems. It is due on Tuesday. If you have questions, please come see me. I'll be there to help you.